Now let me show you how to calculate confidence interval for the variance. I will do it for VADE case. So we have VADE, and we know that the standard deviation for VADE is 9.3, right? 9.3, and the sample size is 10. So we have 9 degrees of freedom. So first of all, we need to calculate the variance. So this is the variance. It's 9.3 squared, which is approximately 86.5. Now, so this is the variance for the sample. What will be the variance for the population? Well, we don't know, but we know that the smallest possible variance for the population is our variance for our sample, then n-1, divided to this statistic, right? The chi-square value. Chi-square for 0.975 and n-1 degrees of freedom. Okay, and then we know that the largest possible value for the population is the same s squared n-1 divided to the 0.025 and n-1 degrees of freedom. So it means that we can write this 86.5 here times 9, because we have 9 degrees of freedom, and 86.5 here times 9. Okay. Now we need to find the chi-square values. Okay. Well, we know that it's the same. It's chi-square distribution. It means that we know the probability, we know degrees of freedom, and we need the statistics. It's ICDF. In our ICDF, it's a co-function. So the co-function for ICDF is chi square. So I just need to run this code, 0.975 and 9, which gives me 19. And then similarly, we can find the chi-square value for the other tail, 0.025, 9 degrees of freedom, which is 2.7. So you can just write 19 here and 2.7 here. And this gives me for the lowest possible value, it's almost 41. I will write it here because I don't have time on the right. I don't have place on the right. And then for this one, it's 288, almost 208. So it means that the sigma square for the population is somewhere in between. It's between 41 and 248 milligrams per liter squared. In this case, it's a squared values, right? So this is and it's for 95% confidence. If you want to calculate the same for the standard deviation, you just take a square root of this. So it will be square root of 41, square root of 288. Okay, which gives approximately 6.4, and 16 point, almost 17. Again, for 95%. Okay, so in our case, we have a standard deviation 9.3, right? But for the population, it's somewhere between 6.4 and 17. We can't say, we can't be more sure because that's the sample size we have. But if we want, we can take a bigger sample size and then calculate it more precisely. Calculate this interval more precisely. So now you know almost everything about how to calculate confidence intervals for different statistics. And let's do some conclusions, and then we will talk how to do all these calculations in R, so you don't have to do it manually every time.